Hello everyone, and welcome back to Masth Electronics. Today, we are going to interface the STM32 microcontroller with the TEA5767 FM radio module, and display the tuned frequency on an OLED screen. Let's go through the components required. Speaker, breadboard, mini USB cable, 5-volt regulator, adapter for the regulator, aux cable taken from an old speaker used as antenna, Nucleo board, black pill STM32 F411CEU6, TEA5767 FM radio module, OLED display, push buttons, jumper wires. The detailed list is available in the description below. Now, we will see the circuit diagram. Connect VCC of radio module to 5V of black pill, SDA to B9, SCL to B8, ground to ground. Connect VCC of OLED to 3.3V of black pill, ground to ground, SDA to B4, SCL to A8. Let's start the hardware connections. Place the black pill and the OLED on the breadboard. Connect the output of the regulator to the black pill. Connect the OLED and radio module to the black pill as shown in the circuit diagram. Connect speaker to radio module. The radio module also comes with a 25 cm antenna, but the signal strength is poor. We need at least a 75 cm antenna for good reception. If you don't have one, you can use an insulated copper wire or an old aux cable from a speaker. I have used an aux cable from an old speaker. Cut it and connect it in a T shape for better signal reception. Now, connect this aux cable to the radio module. Let's connect two push buttons, one for auto tuning and another for next station. The push button has 4 pins. On the back side, you'll see a line. The 2 pins on that side are shorted. So, we use the opposite 2 pins for connection. One side goes to ground. Other side of auto button to A0 of black pill. Other side of next button to A1 of black pill. Now, connect the Nucleo board for flashing. If you're unsure how to do that, check out our previous video. Tap the link in the top right corner, which also explains OLED interfacing in detail. Open STM32 Cube IDE. Go to File, New, STM32 Project. Select STM32 F411CEU6. Click Next. Enter the project name, and click Finish. Since the radio module communicates via I2C, configure PB8 and PB9 for I2C1. Enable I2C1. Leave the rest of the configuration as is. OLED also uses I2C. Configure PB4 and PA8 for I2C3. Enable I2C3. Change I2C speed mode to fast mode. Then configure AO as GPIO input. Set pull up. And label it Auto. Do the same for A1. Label it Next. Save the configuration. The required initialization code will be generated automatically. The complete code is available on GitHub. The link is in the description below. Download and unzip the project. It includes the circuit diagram too. Open main.c. It contains the full code. Let's first try to set a fixed frequency and check if we can hear any sound. Copy this function. This function sets the FM frequency. This converts the desired FM frequency in megahertz to a 14-bit value that the TEA5767 expects. 225,000 is the intermediate frequency used for FM tuning. This formula is from the TEA5767 datasheet. The 5-byte command is formatted as byte 0 for higher 6 bits of frequency variable, byte 1 for lower 8 bits of frequency variable, byte 2 for tuning options that is stereo, injection mode, byte 3 for soft mute, byte 4 for normal mode. Sends the 5-byte command to the TEA5767 over I2C. Address 0x60 shifted left 1 bit for right. Let's call this function with 98.3 MHz as the frequency. Before that, add a 1-second delay to give the module time to power up. OK, let's flash and see the output. Wow, we can hear the radio. That's awesome. Now, let's implement auto-tuning and next station. Copy the required file headers. We are getting this error due to missing headers. Copy the required header files. Now the errors are resolved. This is address of the radio module. In known FM variable, listed down all known FM stations available in Bengaluru, India. This is to get the current FM. This is to store the current FM in string. Auto set best station function is to find the FM station which has highest signal strength and set to that frequency. These hold the best signal strength and corresponding frequency. Clears the screen and shows a tuning status message on OLED. Loops through a list of known FM frequencies. Sets frequency and waits for signal to stabilize. Reads back signal strength from radio module status bytes. Signal is stored in the higher nibble of byte 3. Keeps track of the best station based on signal strength. Locks on the best frequency and formats a display string. Displays the tuned station on OLED. Next station function is used to go to the next FM station. Moves to the next frequency in the known FM list. Sets and formats the new frequency for display. Updates OLED with the new station. There is an error here saying float formatting support is not enabled. So, let's enable that. Go to Project, Properties, C or C++ Build, Settings, MCU or MPU Settings, enable Use Float with printf option. In main loop, add a delay to ensure radio is ready. Set a default frequency, first in the list. Formats the default station. Initializes the OLED. Displays the default station. In the while loop, let's check whether the push buttons are pressed or not. Since buttons are pull up, GPIO is high when unpressed and low when pressed. If auto button is pressed, call auto set best station. Add 200 milliseconds debounce delay to avoid multiple triggers. If next button is pressed, call next station. Let's flash and see our radio. Superb. Our FM radio is working. It's currently playing 91.1 FM. Pressing the next button changes the station.
तो उसकी जो क्वालिटी है मस्टर्ड के अंदर जो क्वालिटी है वो उसके अंदर आ जाए।
Pressing auto tune triggers scanning. And it finds 101.3 FM. Let me go to a station with a song. Ah, that's a nice Kannada song. Today, we learned how to interface the TEA5767 FM radio module with STM32 microcontroller and display the tuned frequency on an OLED screen. If you found this video helpful, give it a thumbs up and subscribe to our channel for more such interesting projects. Have questions or suggestions? Drop them in the comments. Want us to cover something new? Let us know, we'll try to include it in our upcoming videos.